This is Shane Stevens from Google, who's on the Chrome team, and today he's going to be talking about some work that he's been doing with some others at Google and also somebody at Mozilla on improving JavaScript animation APIs for the web.
Just going to put this on. No. I lose my speaker.
Is that one of the animations?
Yeah. Totally. Okay, so thanks for coming. I've been spending a lot of time recently on a new spec called Web Animations. And this spec is intended to unify all of the various declarative animation specs on the web together into one Uber spec. So, this talk, briefly, I'm just going to sort of look at the various approaches that are available on the web platform at the moment for animations. And then I'm going to try and justify why we need yet another animation spec on top of those. And from there, I'll give a broad overview of both who is behind the web animation specification and how the spec is set up, how it's organized, how you might use it. And then if we have time at the end, I just want to sort of talk about 4 current issues that we're working through. And the reason that I want to talk about those is I'm reasonably confident that once we get those issues sorted out, we're pretty close to FPWD, which is sort of W3C speak for version 1. And that once we reach that, then we should start to see some implementations in Mozilla and in Chrome at least, and hopefully on some other platforms as well. Yes, and I just want to apologize up front. This is probably going to be a fairly dry talk without any pretty pictures or fun demos. I'm sorry. But I'm totally happy to be interrupted at any time with questions, just to keep our friendly organizer on his feet. So maybe we can make things fun and interactive that way. So if you have questions, just interrupt me and ask them. Grab the mic first. Okay? So here are the various ways people do animations on the web platform at the moment. We have CSS transitions, CSS animations, SVG animations or smile, and request animation frame. Already? Cool.
What's a smile?
We'll get to that. All right, CSS transitions first. This is what they look like. They're really, really simple, which is it's kind of one of their big advantages and also one of their drawbacks. They're really easy to use, but if you want to do anything non-standard, they're very limiting. So basically what this says, when the specified property, in this case left, changes in value, then the transition will smear that change out over time. And the effect is kind of instantaneous, so if the left value changes again halfway through the transition, you just get a new transition that replaces the old one, right? So if you're going from left 100 pixels to left 200 pixels, and you get to 150 pixels, and the user stops hovering the mouse over the thing, then you get a new transition from 150 pixels back to 100 pixels. You don't get any completion or anything like that. And apart from what's up on this slide, there's basically only 2 other knobs that you can tweak. You can change the timing function so that instead of it being smooth, linear, it might sort of ease in and ease out or something like that. And you can change the delay so it waits a certain amount of time before starting. This is what CSS animations look like. They're basically predefined keyframe sets that are selected via a CSS rule. In this particular case, we're just animating the left value from 100 pixels to 200 pixels over 5 seconds on anything which is of class animated. These are a little bit more powerful than transitions. They've got a few more bells and whistles. You can change the duration, the delay, the timing function, the iteration count, the direction, the play state, and the fill mode. They are still pretty simple though. They can't be triggered from anything. So if you want to use them in any kind of interactive way with the user, you're pretty much going to end up resorting to JavaScript at some point. Which brings us to SVG animations. SVG animations are elements which are inserted into an SVG document. They animate their parent element. In this particular case, that animation is affecting the rectangle that it sits inside. And the opacity is being varied from 1 to 0 over 5 seconds. Cameron can correct me if I get anything wrong.
Yes.
Now, SVG animations are based on a specification called SMILE, or SMIL, or whatever you want. Synchronized Multimedia Integration Language is basically what it means. They're extremely powerful. You can trigger animations off events or even off other animations. You can stack animations so that their effects add together. You can change paths, animate properties, animate attributes. And you can even build what are effectively animation templates that can then be used multiple different times in the one document. But they're not broken. They're not exactly broken, but they're very, very complex. The triggering mechanism, this thing that lets you trigger an animation off another animation, it's called a sync. That mechanism is called sync-based dependencies. Basically, you can set an animation's timing, like its start or its end, to depend upon another animation somehow, and that you can form an arbitrary digraph out of the dependencies, out of the network of dependencies of animations on each other, and this. There's a really complicated sort of cycle resolution algorithm that's part of SMILE that's used to resolve the situation where you get a cycle in dependencies. And basically, you get above a certain threshold in complexity in terms of these animations, which is specified sort of one after the other on the page, but form a graph of dependencies. I'm not sure, actually. Is it NPR?
I don't think so. But it's complex to understand.
Yeah, it's really hard to understand. You get above a certain threshold in terms of the number of animations depending on each other, and it's just really, really hard to reason about what's going on, really hard to make your animation do what you want it to do. And another foible of the specification, maybe not on the same level as sync-based dependencies, is that animations are start time ordered in their effect. Now this is really good. I mean, I should say it's only relevant that this start time ordering occurs when you have multiple animations that are changing the same property on the same element at the same time. It just so happens for various reasons that that's something you want to do a lot of the time. And start time ordering really makes sense when you have events which introduce new behavior. So the user clicks a mouse or something and you put a bunch of new animations on the page. It makes sense to do start time ordering then because you generally want the new stuff to sit on top of the old stuff. That's kind of like a good default. Unfortunately, it gets in the way when you have a bunch of effects which are modifying the same property on the same element, and you've got those effects staggered somehow. So you might have the first effect starting at 0 seconds, the next one at 2 seconds, the next one at 4 seconds. Regardless of which order you write those things down on the page, the 4-second one is always going to override the 2-second one, and the 2-second one is always going to override the 0-second one. And that actually takes a long time to get used to, and there's no real way to work around it except by nesting groups and animating groups so that you're actually animating different elements rather than the same element. So because of the complexity of the specification, it's really, really hard to implement SVG and SMILE correctly. So there's a number of incomplete implementations out there. Actually, as far as I know, of all the major browser vendors, only Mozilla really gets animations in SVG right. And this is mainly because Brian...
Disagree.
WebKit may now.
I would say
President.
most of them get it right, but IE refuse to.
Yes, IE refuses to implement it, but I know that there are some issues with the cycle resolution breaking that even WebKit and Opera don't get right. I mean, we get most of it right, but we don't get all of it right. There are corner cases that we miss. I think the reason Mozilla actually has nailed it is because Brian Birtles is a complete superstar, and he sort of implemented the full thing for his PhD, and he wasn't happy with that implementation, so he went back and did the whole damn thing again. And that works really well. As Cameron was saying, Microsoft has flat out refused to implement SVG animations. And they cite SMILE as the reason for that. They say the SMILE specification is too complicated, we're not going to implement it. Right, and finally there's request animation frame. And this is basically a timeout-based approach that sort of limits the callback rate to the refresh rate. You can see up here, you do something and then you request another animation frame. The obvious drawback here is that all of the animation has to be hand-coded in JavaScript. And the obvious advantage here is that all of the animation is hand-coded in JavaScript. You can do whatever you want. That's what we've got at the moment. So why do we need something new? The most important reason is to unify CSS transitions, CSS animations, and SVG animations into a single underlying engine. The current situation is that we have these three very different approaches to animation, and they do a little bit of everything you might want to do with animation on the web each, but there's no way to link them together. There's no way to make them work with each other. So the purpose of this specification isn't to add necessarily more animation primitives to the web, although eventually we do hope to do that as well. Initially, it's to make sure that the transitions and animations from CSS and SVG animations all work together, have a common language, and can interoperate. Once we've done that, then sure, by unifying the specs, we've provided a single extension point, which means we can add new features more cheaply than if we were trying to add them to all three specs at the same time. And a final thing that I think is useful about this spec is at the moment, cross-browser testing for animations is somewhat woeful. It's really hard to do right, particularly with regards to CSS. Part of what we're doing is providing a JavaScript API to the engine, but it's a declarative JavaScript API. And we think that this is actually going to make testing the various specs much, much easier so that we can get them more genuinely interoperable and doing the same thing.
You say you've got JavaScript APIs for testing. Are you planning to actually spec them and and include them in the specification so that they can be used for purposes other than testing as well?
Yes. So we really hope that most people will want to use the declarative approaches because it's typically easier to accelerate the declarative approaches and make them go really fast and work really smoothly. But there's always going to be the case that there are some use cases that you just cannot capture using a declarative animation API. So the JavaScript API will be there for those users. We hope it's a small set, but probably an important set of users. Okay, so who's behind the spec? It's a W3C spec, so it's from the World Wide Web Consortium, which includes the SVG working group and the CSS working group. And their powers combined form the FX task force, which I think not many people, who's actually heard of the FX task force? Two people, cool. Okay, so basically 3 people. All right, basically SVG does a bunch of stuff, CSS does a bunch of stuff. Some of the stuff that they do, they both do. Right, and the whole point of the FX task force is to try and make sure that there's just one spec for those things rather than an SVG version and a CSS version. So we are operating under the FX task force, and it turns out that's a really natural place because that's exactly what we're trying to do. We're trying to say, hey, let's make all these animations work the same way. Right. So the editors of the specification are Brian Bertels, who I mentioned before, from Mozilla, Dmitry Baranovsky from Adobe, and 3 of us, myself, a guy called Tab Atkins, who's very, very active in the CSS working group, and Alex Danilo, who has written probably the fastest SVG engine in the world. It's not in any browser. So, yeah, I think, it's a pretty good group of people to build an animation specification. I'm not sure what I'm doing on the committee, but the rest of them are pretty cool guys. So let's talk about the fundamentals of the web animation spec. How does it work? How do you drive it? We needed to provide a superset of SVG and CSS functionality. I mean, obviously, if we're going to be replacing the underlying implementations of the SVG and CSS specs, we need to be able to do everything they do. But we actually have an opportunity to change SVG behavior slightly because SVG is about to roll into a grand new version, SVG 2, and the SVG working group has been talking already about some pretty big changes in moving from SVG 1 to SVG 2. So we're hoping to have an opportunity to influence the way that animation changes at the same time. And we also want to, while we're sort of working out how the fundamentals work, we want to look for ways for SVG and CSS to work together, for ways that you can, for example, specify a set of keyframes in CSS, because that's pretty convenient, and then use them as a target from SVG, or vice versa, specify an animation in SVG and trigger it via CSS. So taking all that into account, we defined what's basically a 3-layer model for animations. So at the top you have the timing model, and the timing model basically schedules animations. So you feed it a bunch of parameters, and it decides when your animation is going to run, and then at each point in time, how far through your animation is. On top of the timing model is the effects model, and that takes this time fraction, you're 30% of the way through your animation, and it turns it into a result, a value for a property. And then those values get fed into an animation stack, and the animation stack basically resolves from the bottom up to determine what the output or the final result of all of the animations operating on each property for each element should result in. Okay, so going into the timing model in a little more detail. There are basically two sorts of objects from the perspective of the timing model, animations and groups. Now, animations have an effect as well. They act on a single target, whereas groups sequence animations somehow. But importantly, animation and groups are both timed items, so that you can control the timing of an animation or of a group which contains a bunch of animations. These are the things that you have available to change. These are the parameters of the timing model. So we've added to start time a value start delay, which means we can still maintain start time ordering, but give people another parameter to delay the onset of their animation. I'll talk about that a bit more in a minute. We've got iteration start, iteration count, and iteration duration to control how many times an animation or a group of animations play. Playback rate to control how fast it plays. Direction, which is actually for multiple iterations. So you can say run each iteration forward, run each iteration backward, or run them forward, then backward, then forward, then backward, or backward, then forward, then backward, then forward. Timing function, which is the easy in, easy out sort of stuff, and fill mode, which specifies whether an animation should have an effect before and after its scheduled time period. Looking at synchronization in a bit more detail, I mentioned these timing groups before. So there are two types of timing groups. There are parallel timing groups, which run all of the animations at the same time, and sequential timing groups, which run them one after the other. And the purpose of these is to hopefully replace sync-based dependencies. They give us a way of building a fairly complicated layout of animations without having this whole network effect of things relating to other things. Now, it's a lot less powerful to do this sort of thing. Here we have 3 animations running at the same time, followed by 2 animations running at the same time. And
Can I?
So, yeah.
So previously you said, Microsoft said it was too complicated to implement. Actually, Microsoft was the first one and only one who actually implemented Smile and had a complete implementation of Smile in Internet Explorer up to 7 or 8. They removed it later. And this is actually Smile. So do you think they will implement it again?
So
Did they ever have... Of course.
This is not Smile. If you pick up Smile, you get the whole package. We have drawn a number of ideas from Smile, and I think that's a good thing because they've got a lot of things right. But we've been very careful to avoid some of the pitfalls that are present in Smile. And yes, it is true that Microsoft's motives for deciding not to implement Smile this time could be called into question. But the fact remains they have stated, and they seem to be fairly firm about it, that they're not implementing Smile, that they're not going to do SVG animation. We're hoping that this engine, and I'll come back to this, we have a polyfill version of this engine. It's really small, it's really light, it's really easy to implement. We're hoping this gives them something which is different enough from Smile that they'll look at it and say, yeah, we can do this. But you're absolutely right. A lot of the primitive ideas from here come straight out of Smile. And sequence and par groups in particular are Smile timesheets or something like that. But most browsers don't implement that. So.
Just one quick question. These are elements in HTML, or is that CSS stuff?
That's a really good question. So these are SVG elements, but SVG2 is hoping to import the SVG namespace into the HTML namespace.
Right.
So you'll be able to use these in, hopefully, if everything goes well, you'll be able to use these both in HTML and as SVG.
Okay.
Is that right? Okay. So I'm running low on time. Let's just quickly have a look. I talked about start time. Basically, we provided start delay, and we've locked down start time so that it's pretty hard to use, and we're hoping that the default start time values provided make the sequencing work correctly, and you use start delay to shift things around. Basically, I can talk about that more if you're interested. So recap, we've separated the timing model from the animation model. Support synchronization via layout rather than via network effects, and remove sync-based dependencies, and we've discouraged start time use in favor of start delay use. The effects model is pretty familiar. You've got keyframe animations, path animations, you can group those together, and we've also provided a mechanism of custom animations where you can call out to JavaScript to do whatever you want and basically just make use of the timing model. And the animation stack is the final piece. I mentioned that animation effects get inserted into the stack. They get inserted in start time order and then resolved from bottom up. And basically each animation is applied to the previous value. We have 3 operations: replace, accumulate, and merge. This was the smallest set of operations we needed to support both SVG and CSS. But we could certainly think about adding more in later versions of the spec. And the initial underlying value is basically drawn from computed style. So what happens is you've got your static layout, the computed style generates a value for a property. That gets passed through a set of animation effects, which are controlled by the timing model and generated by the effects model, and then out pops the final result, and that's the animated value. I'm not going to talk about these 4 conundrums because I want to leave some time for questions, but that's them up on the slide. Any questions?
Thank you, Shane.
No questions? Well, I might as well talk about the 4 conundrums.
What are the 4 conundrums?
I'm glad you asked. So the first one is the interface between document and timed item. Initially, we just said, well, at the top of your web document, you have a great big par group and everything gets dropped into that. But then we realized that was pretty bad because you could never clean up animations. So we're trying to work out something that's a little bit nicer, some kind of anonymous or weak link between the document and the animations which are contained within it. Unfortunately, it does add complexity to the spec because there's more concepts that you need to learn. So we're sort of working out a minimal way of doing that. The second conundrum is with timing. I think it's one of the strengths of the specification that the timing model is obviously very separate from the effects model, but we're sort of working out just how separate we should make it, whether we should call out timing as almost a separate object and have all the configuration parameters separate. It's sort of like a juggling between clarity on the one side and simplicity on the other. Media integration is a great big black box at the moment. We don't know how we're going to do it, but we really want to make sure that you can include and synchronize against media elements from HTML5, and do all sorts of scheduling involving video and audio media as well. And the final issue is to make merge work better. I mentioned we had this merge operation, which we need to support SVG2 animations, but it's not really called out in SVG or CSS as an operation you can use, and we're sort of resolving how to make that fit more neatly into the model so that it feels natural, like adding an animation to another animation or just replacing an animation does. So those are our conundrums.
You mentioned it's a new spec, so currently we've got CSS transitions, which I've seen most front enders use, SVG, which I'm not sure. I guess other people use that I haven't run into. But what would be the transition from where we are now to this new spec? Like, will they be implemented in the browser side by side and you flip between one and the other depending on your content, or they'll somehow work together?
The implementation path that we're looking at is basically to replace the implementation of CSS transitions, CSS animations, and SVG Smile with an implementation backed on the Web Animations engine. So if you're just using CSS transitions, you won't see any change. If you're just using CSS animations, likewise, you won't see any change whatsoever. On the other hand, if you want to, you'll start to be able to grab out Web Animations objects, which are the implementations of these animations, and tweak them, or make them work with each other. Schedule a bunch of them in a great big seq group or something like that. Thanks for listening.